All right, everybody, welcome back to another Ask a Dev Unreal Engine tutorial. We are continuing our Octa-bot today. So, as usual, for those of you that are here, let me know how the audio sync is. I think we have our mic levels on and everything's going, so that's good. Before we hop back right in, because we're just continuing, we're not going to belabor a whole bunch of intros. I did want to do a couple quick shout outs. Zaki, our newest Patreon member. Thank you. And then also once again, the forums and the Discord, you are crushing it. It's awesome to see. We have a bunch of new people in there asking questions. Rin's in there, Corsia's in there, Weird One helping out as always, Naroda helping out as always. I saw a great suggestion from David about putting in forums for looking for help. Interestingly enough, Patreon members have just asked for the same thing, so we'll be adding to that. Just thank you. Super huge thank you for everybody being cool in Discord and helping each other out and stuff, which is great. So with that, let's get back into stumbling through our Octa-bot. The goal for today, actually wait, before we do that, well, let me quit Discord so y'all don't get ringing and think it's yours. Rusty off the rails, welcome. Crackshot was here like 20 minutes early. Good to see you all. We're gonna get back into our Octa-bot series and see what we can do about messing up a live tutorial like we always do. All right, here we go. Hopping straight in, where we left off. Let me just double check our... Gaming work, welcome. Okay, so real quick recap, because if you're watching this in sequence, you're probably like, what's up? We were at the point where our Octa-bot, when we move it around, is jumping, and we wanted to spend some time getting our feet to offset. So how are we going to do that? Right now, if we take a look at our rig setup, we have in our forward solve, we're calculating our velocity, our cycle time, and our footlock positions. And specifically in our footlock positions, what I want to point out is we're getting the accumulated cycle time, and then based on this animation curve, it will decide whether or not to unlock the foot for movement. And then if the foot is unlocked over here, it takes also based on the cycle time, and it adds in a vertical amount based on this input graph that we can specify here. Does everybody remember this? Everybody with me? PBM, welcome. Always should be available to watch later, just in case you can't watch it now. So if you recall that, so now what we need to do is we need a way to account for this accumulated time for each foot. That's all we need. All right, and so what we're going to do is we're going to create a new array. So let's add a variable here. And I'm gonna call this foot, not good, foot offset time. Is that times? What did I call this in my notes? Let me double check my notes here. We call this foot cycle offset time. Yeah, we can just call it foot offset time. So this is gonna be a float, and it is going to be an array. So let's make this an array. Okay, let's compile and save this. And then what I'm going to do is I'm going to add a few values to this, 8 of them actually. So remember, these are 0 based, so it's gonna be 0 through 7. And then just for now, for ease of setup, let's just type in a bunch of numbers and see if we can get these feet to move independently. So we'll go 0, 0.2, 0.4, 0.6, and then on the other side, we'll go offset by a little bit. Let's go 0.1, 0.3, 0.5, and 0.7. So these are our foot offset times. So how do we use these? Also, I don't understand what's going on today, but we keep getting this compile error that shows up, but yet when I press compile, it's not there. It says it's fine. So there may be some ghost in the machine stuff. All right, so we have an offset time. Now, what we want to do is in our footlock update, what I want to do is rather than using the accumulated cycle time, I want to use the accumulated cycle time plus the foot offset time per foot. It's that simple. Okay, so let's get our foot offset times that we just made. And what we're going to do is we're going to get the @. So this is going to get the item at the index, and in this case the index is the index for the foot we're working on. And this is going to give us a value. Alright, and all we're going to do is we're going to add this. And if we plug this in, it's not going to quite work the way we expect, because we also need to plug this in something else. Actually, let's just see what it looks like just for fun. Okay. Yeah, you can kind of see some of them are trying to go. Like there is a little bit of a delay, but not quite what we want. So there's a couple reasons for this. So first off, probably the easiest thing to think about this is, remember our cycle time is going 0, 0.1, 0.2, 0.3, 0.4. It's counting up to 1. And then if we take our foot offset time, and let's just take not the 0 case, let's take the 0.2 case. If this starts at 0 and our foot offset is 0.2, this is going to start at 0.2. And then it's going to go 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And then it's going to get to 0.1, but it's going to go past 1. So it's going to basically hang out past 1. And let's take another example. Let's look at our 0.5 example. When we get to if we start at 0.5, we're going to go 0.6, 7, 8, 9, 1. And then we're going to basically be well beyond 1. So the same way that we created a loop for our cycle time using the mod, we're going to do the same thing here. So as an example, I think all we're going to do here is I'm going to use the % or type in modulo, and I'm going to mod this with 1 and plug this in instead. Now, what does this do for us? Okay. So what this does is, when we have taking the 0.5 case, if we're starting at 0 for our accumulated time, we're starting with 0.5 for our offset. So technically when we get to this add, we're at 0.5. So the first, let's go through 10 times, 1/10 each. So 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Okay, and then what's going to happen is at 1.0 it's actually 0 because there's 0 offset. And then 1.1 is going to be the output. It's going to go 0.1, 1.2 is going to be 0.2, 1.3. So it's basically circling back around. That's what this is doing. Because much the same way we did it with accumulated time, we're doing the same thing here. I'm going to copy this because we need to do this in one more place. Down here where we're doing our vertical offset, we also want to use the right value for this, because if we don't, what ends up happening is we're going to only be getting partial parts of the verticality of each foot. Let's just see if we can see that happening though. Okay, so you can see, we can see the blue stuff's, some of them sort of offsetting, but they're also snapping. So there's a lot of kind of snapping going on too. It's kind of hard to follow, but there is a little bit of an offset that it's trying to do. And there's a couple fixes that we're going to put in there, but I think we're also getting a snapping on the verticalness too. So let's just go ahead and put this in here. So paste, this is, all I did was pick those points, Control-C, Control-V. I'm going to plug this in here. Okay, and then we got to make sure we plug in our index. Remember, our index is just this index. So this is going to get our vertical. To match that time. Okay, and then what we're going to do is, now that we've got those, there is, where are we, update, foot target, is that what we need? Okay, so now let's see what that looks like when we play. Also, we have an initialization problem. So you can kind of see the feet are starting, they're starting to move out of sequence. This is what we want. However, we do have a couple of issues that are happening. It does work both ways, by the way. Okay, but one of the problems that we're having is our feet, look at how far the blue boxes are moving or the speed. None of their speed is being taken into account as far as how fast the feet move. It all moves at 50, I believe. And I think from last time we saw that it had, I think we had hard-coded that to 50 units. So what we need to do is, but we can kind of see it starting to work. It's starting to work. We got our offsets in there, which is great. File, save, everything often. Let's see where we're at. Okay. Okay. Rusty has a question. Is there a way to see which index corresponds to which leg, or do you just have to be extra careful when setting up? Well, the index is based on the original foot bones array. So however you set that up, so for example, in our, where do we do it? It's right here. This item array that we created, when we originally picked our legs, we know that it's going to be left leg A, B, C, D, right leg A, B, C, D. So the order in which we fill in this original array, that's the order in which that our indices would be set up. And this won't change because we never change this. So, okay, so compile and save. Okay, cool. Now, so we've got our foot offsets. They're kind of offsetting a little bit, but we need to take into account our distances. And what we're doing right now is let's take a look at our foot targets. Let's see if we can find this. This is part of the problem with doing this stuff piecemeal. So here's our cycle distance. And then we have our cycle time. We're scaling that. Okay, here's our world velocity unit vector multiplied by the cycle distance. Okay. If we multiply that by the I think we want to do one more multiply in here, you all. Give me 1 second to think. We have our distance, we're multiplying it. We're taking our accumulated cycle time. We need to scale it by that? Is that what we're doing? We're scaling it by our accumulated cycle time. Okay, cool. So this accumulated cycle time where we're scaling it, we also need to do our foot offsets here as well. Because it's scaling it by the wrong number. It's scaling it by just 0 and 0, 1 instead of the offset version of it. So I'm going to paste. Okay, I'm not going to paste. I'm going to go back and copy and paste. This is what I want. And in our foot targets where we're getting this accumulated cycle time, we're going to do the same thing here. Paste this in. And we need our foot index to get the right one. And we're just going to feed that in instead. So we're no longer using we're using the correct scaling now. Basically just offsetting it. That gets multiplied or scaled. Let's see here. This comes in, that scales our world velocity, which is cool. And then we are adding in, what is this? We're adding that vector to our foot bones. And then we're setting that. Okay, cool. Compile and save. Let's see what that looks like now. There we go. We're getting there. We're getting there. Okay, it's starting to walk, which is cool. So Weird One had asked a question, said they were interested in why we were going to use the caches. One of the reasons we're using the caches is because we're scaling the vector based on the total distance the foot traveled from. And in order to have the total distance the foot traveled from, we need where it left from and where it's going to, so that we can set where it's going to get put down. Now, if you'll notice though, there is a problem. Our foot seems to be overstretching. And that's because what we're doing is we're going, let's see if we can see this. It's going to be hard to see. If we look at 1 foot, it's basically going only in front. It's not actually traveling behind at all. Okay, so what I want to try to do is, so it's basically leading and not dragging very far behind. So here's what I want to do. I want to cut that distance in half, I think. Let's try that. Let's double check that. Let me see if this is, so here's our foot bone. We're taking that to the world, and then we're going to, actually let's take where it is. Let's see here, we're going to take that, we're going to, from the world, you know, before we do that, what I mean here is, let's see here, where's our scale? We could, right now, the whole 50 units or the whole velocity units is going forward, but we kind of want some of it to be behind. So we may want to cut that in half by scaling this again by 0.5, for example. But before we do that, let's see if we can get our feet to interpolate a little bit nicer for us. So what we're going to do is, after we do our scaling, I need to make sure we have the right thing. Here's our 2 world. What's this ad doing, y'all? Okay, this ad gives us our start point for our vector. That's what this does. Okay, and then with that, what we're going to do is let's interpolate from where we are to where we're going to. Okay, so let's get our current foot location. I just want to try to see if this smooths us out a little bit. And then let's interpolate. So we're going to interpolate from where we are to where we're going, and then what we're going to do is plug that in, and then the speed at which we'll do this, let's just do this at 0.1, for example. I just want to see something. And we also need the foot index for it to be proper. Compile and save. And let's see here. Oh, look at that. Okay, so that is looking better. Our feet are moving way better. That little interpolation is helping our feet travel smoothly. So this is looking pretty good. Now, if you watch the front left foot, it's picking up and setting down like too quickly. It's almost like it's not reacting based on the speed at which we're moving. So if we're moving at about 50, it seems about right. It's like if we move at this speed, it looks pretty good. So something is wrong with the way, we have a couple things to chase down. Something is wrong with the way that we are calculating how far the feet go or how fast they are translating, as well as our initial state. But we're getting there. We're getting there, which is cool. So let's make sure we've compiled and saved, and let's see what we're missing. Couple of things. Are our feet, hold on, let's double check something. Okay, our feet seem to be moving even when they're planted, which is not what we want. So let's do this. Wait, no, that's not what's happening. That's fine. They're not moving when we're not moving, that's fine. Okay, that's good. Somewhere in here we have a calculation that's wrong in the distance that our feet travel. Like that is a thing. Also, they never get behind. So the green box, remember these green boxes? So this green box right here that I've zoomed in on, this green box represents the default position for that foot. And you'll notice that this box goes in front, and then our leg never drags behind that box. It never gets behind that green box. It's always in front from then on. So for whichever direction it's going. So what we're not accounting for is we're not accounting for the ability for the foot to lag behind the reference point right now. That's part of it. So let's see if we can find where we missed that. And let me double check our questions. Dawui, I don't even know how to say that name. Yes, I still love kite surfing. That is some old school stuff if you're bringing up the kite surfing. Okay, cool. So we got to figure out what's going on with our foot distance, and it has something to do with our velocity calculation or something. So let me see if we can do some live troubleshooting here. And oh, what? What is this? Oh, you know what? It looks like it pasted in that to here. Okay, so let's check our world velocity. Let's just double check that. I don't think there's going to be anything fancy in here. I want to check our cycle duration. Okay, so we have our world velocity. We have our world velocity magnitude and our previous location. We're drawing a line. Okay, I think this is what we're missing. So right now, if we're moving really fast, we need our foot to move really fast. So let's see if we can trace this down. Cycle duration. Let's find. So I'm right clicking on it. I'm finding references by name. I do this all the time. I want to see where this is being used. So over here, our cycle duration is being used when we calculate our updated cycle time. However, nowhere is that being adjusted based on our character's velocity. In other words, the faster the character's moving, the faster we want the feet to go, and vice versa. The slower the character's going, the slower we want the feet to go. That's one way to do it. Or you could also do it the further they travel or whatever. So there's more than one way to solve this problem, but we're going to do it where if the character's moving fast, the feet move fast. So here's what we need to do. Right now, our cycle duration is only being used, it's not being set, and so it's only using a default value of 1 second. So as long as we're moving our character at the exact speed of velocity that works for 1 second, the feet look pretty good. So that's not going to cut it. What we want to do is in our world velocity, let's make some room here, and let's update our cycle time based on all of these values that we just calculated. Okay, so let's take our cycle duration. Ultimately, we're going to end up setting it. This is what we're going to do. We're going to set this. And what we're going to set it to is a little bit of the math stuffs. So let's take our cycle distance, and this is just back to the whole rate times time equals distance that you learned probably in elementary school, okay? So we're going to multiply this by, I'm going to double this. I'm going to double it. Well, do I need to double this? No, I'm not going to do this. I'm not going to double it. I think this may work without it, and then I don't have to do that. So let's just start with this. So let's take this and let's divide this by, what we're going to divide it by is we're going to divide it by the world velocity magnitude. Now, here's our world velocity magnitude. Okay, so this is rate times time equals distance. So this is the distance divided by the rate is equal to the time. Yes, that works out. That's the math. Okay, because if we flip that, that's the math. All right, and then what we're going to do is we're basically just going to divide these two, and then we're going to use this to set our cycle duration. However, there's a little bit of an issue here, because what happens if our character is not moving? Then we get 0. And if you recall, dividing anything by 0 is a bad idea. All right, so here's what we're going to do. Let's just put in some safety. There used to be a safe divide, but I haven't seen it in ControlRig. Safe? No, it doesn't exist. So here's what we'll do. We're just going to do nearly 0 is nearly 0. And if that's true, I'm not going to use a branch. I'm just going to use an if. So if we right click and type in if, This is an if that will allow us to choose between two values. If it's nearly 0, we're going to set our true to one thing, and if not, we're going to set it to this. All right, the minute we connect this float to this if, it converts the whole thing to a float. So if our world velocity is nearly 0, we're going to set our true condition to be 1. We'll see what that does for ramification flow. Otherwise, it's going to be our world velocity magnitude, and we're going to divide our distance by that, and that is going to set our cycle duration. Okay, so once again, this is just rate times time equals distance. So let's compile and save this. And just that one change alone probably changes the way that our character responds. Look at that. Woohoo! Okay, so what's happening is the faster the character goes, the faster the feet go up and down, and the slower the character goes, the slower the feet go up and down. Now, there's some things I'm not liking. We're still missing a couple of tweaks in here, but we're close. We're getting so much closer. And really right now what it is it's just kind of like refinement. This is also why I originally drew these boxes in the beginning, because I can see when I go slow, the blue box, if we pick, and it might be easier, and by the way, from a debugging standpoint, it might be easier if we come back and we take all of our foot times and we set them all back to 0. So we know the offsets are working. That's cool. But what's not working is the way our feet are transitioning. And rather than trying to keep track of 8 feet, if we do them all, let's see what's happening, because now they're doing the same thing. So now, as we're traveling forward, they hit the ground, they're planted, they come off the ground, even though it seems early. Or it's not early. What's happening is they're never getting behind. It's like I said, they're coming off the ground, and when they come off the ground, they're drifting backwards. Okay, so from a troubleshooting standpoint, let's see what we missed. So in our, there's actually a bunch of things that we might have missed. It could be a problem with our foot locks. Could be a problem with the way we're caching stuff. So let's just dig in. Before I do that, let me double check the chat for question. Garcall, welcome to the stream. I'm glad the videos are cool. Okay, so let's see here. We're pretty good with our, I'm pretty happy with our world velocity stuff. That looks good. Our cycle time is pretty boring. It's just setting the accumulated cycle time. There shouldn't be anything crazy going on in here. Yeah, so that's pretty straightforward. So really the only two things that are left are our effectors. That's too easy. That's not it. Error. Array size 2049. Okay, that's a problem. Okay, so this is one problem. We want to fix this. So the array for the get effectors is getting bigger and bigger and bigger and bigger when we mouse over that. Let's fix that right now. So in our initialization, let's double check. This is what we're going to do. We're going to right click on effectors and we're going to find references by name. Okay, so everywhere that this thing's referenced, I want to look at it. So we're adding 2 effectors here. We are using the effectors there. We're setting the effector at this index here. And we are adding one to it here. Ah, interesting. You know what? Let's try something. Let's first reset our effectors just to make sure. So let's get this and reset it. Okay, let's compile that. Save it. Now we have to recreate this. Let's play again. Let's see if we have the same problem. Stop. Okay, I don't see that problem anymore. All right, so back to what we were doing. Cycle time we said was good. So let's check. It looks like our compile error has disappeared. Okay, so I believe somewhere in this foot locking logic is where we're missing the piece that lets our foot fall behind, if you will, or changes the distance. So let's see if we can figure out where it is. And so as part of this, we're going to have to go through our logic again. So here we go. This is our curve. I do want to change the shape of this a little bit though. Let's go like this instead. Okay, so if our time is greater, if this value, like, so our time, this is our cumulative time, it's going 0, 1, 2, 3, 4. When I say 0, 1, 2, 3, 4, think of it as 10 based. You get to 10, 10 is 1, okay? So I'm saying 0, 0.1, 0.2, 0.3, 0.4, 0.5, all the way to 10. So basically this value comes in here, it evaluates this curve, it's 0 all the way up to this 0.2 mark. Now, if it's greater than 0, well, first, is our foot locked? If our foot is locked, and it starts off as locked, it's true, and this is greater than 0, then we're going to say the foot is not locked. We're going to update the foot cache that one time, which basically snapshots where the foot is right now. All right? And then our error is back. We're going to have to figure out what is going on with that. And then when we update, then we're going to update our foot target at that time. So if we look at our foot target, this is potentially the first spot where we have a problem. So let's take a look at this. So when we look at our target, at the core, if our velocity magnitude is greater than 0.1, so if we're actually moving, ultimately what we're going to be doing is we're going to be setting the foot location, the foot target location. That's great. Now what is the value we're setting it to? This is the interpolate that we were just doing. That's fine. Oh, you know what? It's also possible we don't want to do anything unless our velocity is greater than 0. Let's add that in. This is one thing we might want to do. Okay, so that's one. I'll come back to that in a second and explain to you what I'm thinking. 2 is we want to do some line traces eventually, but we're not doing them right now. We have our scale, we have our accumulated cycle time, we have our offset, our cycle distance. So here's our world velocity and our cycle distance. Is that what we want? Do we really want that cycle distance? I want to try something, y'all. Just for testing, I'm going to try to put something in here to match my original notes. So let's get a curve. Evaluate curve. And let's get our world velocity magnitude and plug this in. So when our world velocity magnitude is 0, our distance would be 0 in this case. We're going to multiply this by our distance. Okay, and if our world velocity is 2,000, oh, okay, we can use this to clamp this. Let's say this is 10. So when we come in here, if our world velocity is 2,000, this is going to clamp this down to 10. I don't think that's going to help us. Let's just double check and see what that looks like. Actually, that made it worse. Okay, that's not what we want. Oh, actually, yes, it is. 2,000 would be our max. This is basically going to remap it. I don't think we need this, though. Actually, I'm not going to lie. That kind of looks okay. That kind of looks okay, y'all. Okay, hold on a second. We got to go back and remember why that works. Okay, so our world velocity magnitude is, let's just say, let's put a print. I want to know how fast we're moving. So back here, enter calculate world velocity. Let's see, once we do all this stuff, let's just put a print in here. Print. And we're going to print our world velocity magnitude. And let's press play. Okay, so when I'm moving this fast, that's about 50. If I go fast, it looks like it's in the, all right, so fast, here's what we're gonna do. We're gonna go really fast a couple times and escape. Okay, now, what I wanna show you is in the output log, I think it is, you can see the values that are printing. So when I'm moving really fast, it's somewhere between 1,000 and 2,000. Now that we know that, by the way, compile and save, let's get rid of this print. If we go back to our math, we can try to understand why that worked. Okay, so what happens is we get a world velocity magnitude of about somewhere between 1,000 and 2,000. Let's call it 2,000. So the 2,000 gets remapped to a 10. 10 gets multiplied by our cycle distance, and then that gets multiplied by our world unit velocity. I don't think we need this. I think that there's better math in here, but I also don't want to belabor this too much from the standpoint of I don't want to spend the whole time just doing about math, because the whole goal of this is to get the procedural control rig stuff to work, which is kind of what we're going, which is kind of what's happening. In other words, it is kind of working. So let's see here. But if we look at this, our cycle distance is 50. That's how far the foot can go. If our velocity is $50, $100, whatever it is, we're going to multiply that. Oh, so the whole point of this is to try to normalize this. Basically what all this does is this kind of basically takes the velocity, direction, takes the distance with some clamping on it based on our max speed, and then kind of remaps it so that we're getting a distance offset that is equal to, oh, it gives us a value that we then multiply by our accumulated cycle time. So that gets us how far forward it's supposed to go. Okay, and then that's getting scaled. That's getting scaled by the amount of time that's passed for that cycle. Now, the one thing that I had mentioned in here was adding in another scale here. This was to make it half the distance, so that the idea would be half is up front and half is in the back. But let's just see something here. So now it plants, it falls behind, it plants, it falls behind. It doesn't go in front. Okay, so let's go back. Let's change this to 1. Compile and save. Okay. All right, it plants, goes a little bit in front, a little bit in front, a little bit in front. All right, that one's better. I don't think we need that scale. Let's take this out. Actually, we'll just leave that right there. Okay, so where are we at? Our feet are working. We can bring back our offsets. I think that's fine. So we just do that by typing these back in. So here's our foot offset times: 0, 0.2, 0.4, 0.6, 0.1, 0.3, 0.5, 0.7. For example, compile and save. When we go back and we press play, that looks pretty good, y'all. Okay, now there's a couple of things that I want to take a look at. One is, why is the character initialized way off in the middle of nowhere? We need to figure that out. It should not be starting over there. And then 2, we do need to solve this compile error that keeps happening as a result of, I believe, adding this end effector. And what's happening is, rather than adding this end effector, I think what we want to do is we want to update it. But before we do that, yeah, okay, this is the problem. This is a big mistake right here. All right, sometime past me made a mistake and we did an add here. This is not what we want to do. What we actually want to do is we want to add. So what happens is, look at that, there's the error. Every single time, and this is why for loops and logic errors are fun. Okay, every single time we come through this forward solve, it's adding the head back to the list. So this vector is now 2,000 units long. It's greater than 2,000, which is longer than, which is bigger than the size this should be. So we need to rewire this a little bit. All right, and the way we need to rewire this is, what we need to do is, in the beginning, when we do our initialization, that's when we want to add the initial spot for the head. So let's take this and copy it. All right, I'm just going to disconnect this for right now. And then up here, interesting, that goes nowhere. Foot bones. Okay, so here's our initialization. This is our construction script. Why is that an error? Okay, there was another error there. We're gonna have to check our foot cache locations as well, make sure we're not doing the same thing. So we come through, we reset. Then we reset the foot bones. Then for each foot bone, we go through and do our thing. When we're done, we need to add in our head bone right here. This is where we're going to add our effectors. So let's make some room. Okay, and all we're going to do is add in our head bone. So this will add in the head bone to the list, and it will get the initial position, and we can get the initial position of the head bone here. We'll call that like that. And that may actually even help. Yeah, that even helps with our initialization. So it's in the right place, which is cool. So now we just need to fix the initialization of our feet. So that's part of it. So that helped with the head bone. And then what we can do is, if we reconnect our feet, we're not going to do the add here. But what we're going to do is we're going to change this. So let me compile and save. We're skipping it for right now just to see the debug. There we go. Cool. Okay, now, if we wanted to complete this, like correctly, or however you want to call it, what we would do is, in this forward solve, rather than doing the add, what we would do is we would set. So let's take the end effectors, and we're going to set at. And we can get rid of this. And this is where what we want to do is, we want to set the head one. And remember, the head one is the last one that we added. So if we get the number of items in this array and we subtract 1, that's going to give us the last one. And the reason we're subtracting 1 is because it's 0 based. So if there's 8 feet plus a head, which is 9, right? But that's not 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not 9. Remember, it's 0 based. So what we need to do is, we start at 0. It's 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's the 8. So we have to subtract 1 to get the 8th unit. That's our head piece. So we'll go ahead and grab that. And what we're going to do is, we're going to set the value to be the head location for now. But we can also do a nice little interpolate later on this one too. But for now, we'll just do this. And the bone is going to be the head bone, which is here. So we can feed into this. This will update. This will feed into here. So right before we do full body IK, the last thing we're doing is we're updating our head position. I think this is everything we need. So let me just double check. Yeah. So compile and save. Let's go back to our game, press play. And we're good to go. Now, we still have one more problem with our initialization, which is our feet. Like, why are our feet, basically our feet, you can see they're all starting at 0. So somewhere in our initialization, the values that we were getting for our feet are not correct. But before we go do that, let's see what we're doing. Okay, so the way Memo Dev, welcome to the stream. Thanks for hopping in. Andy, good to see you. Andy, by the way, you all, has been posting some amazing stuff and summaries in the ControlRig videos, like his write-up on projecting to parent and some of the super astute stuff. So thanks for throwing your comments in. As far as how did we come up with the offsets for each foot, Chronomitz, welcome to the stream. The way we came up with them was, it's a combination of things. Some of it's, one is as, like, for example, what would I do? I would do, if I was going to try to figure out what I was going to use for offsets, let's go to good old-fashioned Google. I'll bring it up for you all to see. Position. That's not what I'm looking for. I'm looking for animated spider videos. So you look at reference. You either find a real spider, or you find an animated one. This one is a great one. I think it's this one.
Hey guys, so I thought I would do this.
Nope, that's not it. Let me see. I think it's this one. Here it is. So you look at reference. You either look at real life reference or some other reference. So basically you can see in this particular reference, you can kind of basically figure out what the timing is based on the times, right? So I just thought this was a really cool reference. I don't know how realistic this is compared to like an actual spider, but you can literally calculate the keyframes in here, because not only did this person or group post their stuff and put it in slow-mo, but also their frames are here. So you can calculate the frame for each of these based on the total time, which is great. So that's one way. Another great answer to this is trial and error. So one of the things that I did, also I'll show you some cool stuff with this in a second. One of the things that I did initially is I came up with the foot offset times, and I literally, initially I think I started with like 0.1, 0.2, and it wasn't enough. And so I just started experimenting with the times that made it feel the best. So that's that. And then as far as is C++ necessary for game development, it depends on which part of game development you're in. We can talk more about that after if we have more time, or you can throw that. There's a lot of great discussions about C++ in Discord. So let's figure out what's going on with our initialization for our feet. All good questions, you all. Okay, so in our feet, we're setting these all to each bone's global space. Do we want this to be initial? Is that all it is? Nope, that's not it. Whoa. Let me see what we want this to be. So that's our head. You know what? I don't even think when I originally did this, oh, it's because, you know what? I think we're initializing all of this stuff maybe to the wrong thing. Hold on a second. We lock our feet, then we're creating our effectors. So here's our effectors, and then we're adding interesting. How in the world? Let's say here. For each one, we're getting our foot world locations, caches, etc. We're adding it here, and then we're setting it. But what is going on with this? And then we're setting it here. I want to see something. This foot target location, let's find references by name. And we're going to do, the same little bit of trouble. I can't believe we haven't crashed yet, you all. This is amazing. Okay, so what I want to make sure is, okay, that's a reset. This is an add. So we have one add. This is a get. This is another get. And this is another get. So the only add that we have is here. And this add happens inside this for loop based on the number of items in the item array. Interesting. I don't see anything that would cause us to add an extra thing for foot targets. Let's check our caches real quick. We're going to find them by name. That's the reset. That's the initial add. This is a get. And that's a set. That's fine. And this is update foot cache set at, and we're getting the world, we're getting the foot current world location to set the cache. Okay, that's fine. And let's do the same thing with the foot world current. So there's the reset. This is the add. That's the get. That's a set. That's a set. And that's a get. Okay. I don't see anything there that would cause us to have extras in our arrays, so I think that was probably left over from before. We just need to figure out why. I need to figure out where we were doing these adds. Maybe we don't need to do adds. Oh, you know what? Hold on a second. I know what we did. Oh, I know what's wrong. Okay, here's the problem. We are setting all of, local space, global or rig space, and world space is such a mind game to keep track of in these things. Remember, all of these locations, and this is why I wrote it in the name. It's world location, foot cache world location, foot target world location, foot current world location. But look at what I'm getting. I'm getting the position, but I'm not translating it to the world. I'm setting it. So what we need to do is we need a to world in here. To world. Okay, and with that, we can plug this in. So now what's happening is when we get, because remember, when we get a bone transform, it's in global space. Even if it was in local space, it still wouldn't be right. So we're getting it in global space. So when we compile and we save this and we go back to our game, do our feet start in the right place? They do. Look at that. Okay, so once again, super important. Remember, when you're getting and setting values on transforms, make sure that we are actually getting and setting values on in the proper space, whether it be rig or world or local. So now there's a couple things that we've got going. So one thing we got going is if you look at this, when we stop moving, our feet stop moving. So one thing that we want to do is we want the idea of a settle time. We want the idea of when our character is done moving, that because remember, this foot, the reason this is up here in space is because remember, we were, as long as we were moving forward, we were translating the foot up in code or in blueprint. Let's escape out. Let's make this smaller so you can see it. When we were doing this, it's in our here, rig, update our foot lock positions here, right? This is based on basically the percentage of the way we are through the cycle time plus the offset. So if we're halfway through, we are going to be at full height of a step. But then what happens is if our character stops moving, the foot is still up in the air. So the foot is still up in the air if we stop moving. Okay, and that's why it stops here. So we would like to add the idea of an idle reset, where maybe after a certain amount of time, this foot just naturally settles back to the ground, as an example. The other thing I want to show you while we're in here is look at what happens when our character turns. Nothing. It kind of doesn't work. It's trying to do something, but it doesn't work. So for those of you that can remember however many weeks ago we started this adventure, the reason that is happening is because, remember, our character position is based off of the full body IK placement of all the feet and the head. But remember, our head is basically swiveling in place, and all of that stuff and the foot movement is based on the velocity of the character. And if you remember, one of the things that I said very early on is we made this node called the rig space ref node. I want to draw your attention to it. Remember, it's right here at the origin. Okay, so if we are rotating our character, what is the translational velocity on this control if we are only rotating and it's at the exact pivot point of our capsule? Hopefully you're all like, there's no translational velocity. There's rotational velocity, but there's no translational velocity. So what I was originally thinking when we were doing this was, if there was a way we could get translational velocity for free, how might that work? Well, so we have two options here. One, we could do something crazy, like try to calculate the rotational velocity of our character as well. And that freaks me out a little bit. I don't want to do that because math. So what if we cheated? What if we took this rig space reference and rather than having it at the origin, we put it out in front of our character, the same distance as our foot, roughly. Well, the interesting thing is, now when we move through space, this thing's still going to move relative to the character the exact same amount translationally. But now when we rotate our character, this control is also going to move through space. So by moving that, I've got a set on it somewhere. So let's find where we're setting this. Find reference. What am I doing? Find rig space ref. Here we go. We need to set this, I believe, because, I know what we need to do. If we move it out here, we can move it out here. What we can do is over here, I think we right click. We can do, there's two ways we can do this. We can say set offsets from transcurrent. So that's going to make it so that's where it sits now, even when we're zeroed out. So let's save that and let's press play. Oh, it doesn't like that. For some reason it is rotated. We need to fix that. Let's go back. Did this thing get rotated? Offset. No. Why would that rotate? I'm not expecting that to rotate, you all. Rig space reference. Hold on. Let's figure out what's going on here. Let's go back to our construction event. Maybe we don't do this way. Let's reset this. Let's go back to 0 on this. And let's just do this in the construction script instead. Let's see here. In our construction script, what I'm going to do is let's set the transform. And the transform we're going to be setting for the item is going to be a control, and the control is going to be our rig space ref, and I'm going to set it in global space 000, and let's change this to a transform, We'll zero that out, translate, and let's do 50 in Y. 50. And then keep all that and compile. Okay. That seems reasonable. I also want to save that. Okay. I have no idea why translating it did that, but for some reason it was different. Okay, so our feet move the same. All right, back to what I was talking about. Our feet move the same, but now watch what happens when we rotate our character. The feet rotate. The feet actually pick up and move. Why is that? They're moving. Look at the difference in where this line is drawn from. See this green line? Remember this debug line we drew? Okay, so you see how when I move, look at where the line starts from. It's starting from the character, in front of the character, where we positioned that bone, or that control. And so now when we rotate, watch what happens. It's rotating around. Now I do want to double check one thing as far as this debug line may be misleading. But the overall point is, by moving the rig reference, and that's why we created that in the beginning, by moving it out away from the origin, now when our character rotates, that rig reference control don't have to calculate the rotational velocity of this thing. It just works because that point is moving at roughly the exact speed that my character is rotating. So I'm able to take this and move this around in world space, and my character will be able to turn, and the foot plants will work, and all this kind of stuff, which is kind of cool. It's kind of cool. Okay, so let's stop playing. Let's compile. How are we doing time-wise? Whoa, okay. Oh, sounds out of sync. All right. Let's try this. Let's try a quick reset so we can wrap it up. All right, let's do this. If I don't come back, thanks for hopping in. I'm gonna try to reset the sound. Next time it will be our last one for Octa-bot. It'll just be cleanup. So let me try to reset this real quick, and I'll come back to trying to answer any questions you all have before we actually call it a full wrap. Okay, are we back? And are we back in sync? Okay, I saw heart, so I think that maybe we're at least back, and then we're back in sync too. Okay, perfect. All right, so does that make sense, y'all, as far as why I originally created that reference node so that we could use that to cheat our angular velocity? Does that make sense to everybody? We could absolutely calculate angular velocity, but I don't know, I just thought about it. I was like, why? Why do that? Why not just do it this way? So this seems to be working. It's great. There are a couple things that we have for future just to finish cleaning up. One is next week what we'll do is we'll do that idle reset. So once our character gets to a point where they've stopped for a little bit, we'll just have them put their feet back down. There's a couple things that we can do to add in a little bit of undulation for the head, which I think will be fun. And we can go from there. And actually, if we take the head out, now that I think about it, we might, maybe I can show you, let me see, let me try this. Let me take the head out real quick. Let's do this. Let's take the head out real quick. I want to see. So if we take out the head here, and we skip the head here, and we go back to play, compile, save, and play. All right, do you see how the character bobbles up and down? This is cool. You can see how the character is kind of bobbing up and down. it may be hard to see. Let me zoom in really closely. This comes for, you could kind of say free, because what's happening is, remember, this full body IK is evaluating based on all of these foot positions with no account for the head right now. So as the feet move, we get a little bit of vertical up and down in the head, but it's not very controllable. But it is natural, but maybe we don't want that. So what happens is, by connecting in the head, as we had done up here, if we connect it back in now, what we've done is we've now stabilized our full body IK, because now we're taking into account the head position. And so then when we look at it now, our feet, oh, actually, it just did it live. So now we have 0 head motion. So we have a couple options. We can say that full body IK is natural and cool, or we can add in our own head up and down stuff. So things that we got for cleanup next week. We have our idle reset. We have our head up and down bobbing that we may want to add in if we wanted to, or we could use the natural one, you can choose. And then the third thing is, we need to be able to handle uneven ground. So if we take our character and we walk over here, we zoom in, you'll notice that the feet go through this piece behind us. Well, it's kind of hard to see. Let me see if I can. All right, there you go. You can see these back legs are going through this platform. So what we need to do is we need to do a line trace. And we're going to do that 2 different ways. We're going to do a line trace so that we can get what our feet are going through, and then I'm also going to do a different, just a slight modification to it, so that if our character's walking by a wall or something that's too close, the leg will actually go up onto the wall. I think we can get through all of that next week. So that wraps up today's somewhat chaotic tutorial, but at least we got our character walking and moving now, which is really cool. And again, the goal of this was to get to a procedural walk cycle for, you know, an 8-legged character without setting any keyframes and things like that. I was hoping that I would be able to show you all, as we layered in these things, like the problems that you were going to run into. I'm interested in your feedback on this. Rather than a completely canned tutorial where we do everything exactly in the right order with no mistakes, versus this method where we run into problems, we troubleshoot them, etc. What you all think? Maybe what I'll do is I'll do a future tutorial on it's a little bit more canned, but I'm kind of like, no, just go check out Lincoln's stuff. It's amazing. Lincoln's stuff is awesome. All right, so let's see. What do we got for questions before we wrap up? Racine, welcome to the stream. How to make a flexible ball rig. I'm not sure what flexible ball means, but depending on what that is. Rusty, thanks for hopping in if you're hopping out. Can't wait to see how you will make the legs go on the walls though. We're just going to use a sphere trace actually, but I'm going to show you kind of a difference in how it works. Yeah, Udemy has there's actually some really cool stuff on Udemy, you all. So, you know what, that's the other thing I want to make sure you all know. A lot of times people are like, hey, can I post another course, etc. in the Discord, etc. Like, dude, this is all about us being out here learning. So, absolutely, whatever we can do to help each other. The goal here is, like, I very much consider myself in this with you all. I am learning as much as you all. I spent most of my career in Maya. And so, especially with the control rig stuff, like going through this, etc., I'm learning a ton. So everywhere we can learn would be great. Okay. All right. So before we wrap up, were there any last minute questions? Otherwise, we will call today. I don't know. Today went pretty well. We got our character walking and we didn't crash, and I don't know. Like, we've had worse live streams, you all. We got one audio sync thing. All right. Yes. Dewey, if you go back to the initial stream for this Octa-bot series, I put a link down to link and stuff in the description. It's really good. Okay, so it doesn't look like we have any other questions. As usual, this is not the end. This tutorial will be on the, it'll stay in the live section. Don't forget to check out the live section. Also, as always, thanks for your support. Patreon, Discord, spreading the word as usual. It's awesome. And also, you know, if you have questions, you know, I try to make sure I respond to all the comments in all the videos, etc., as well as, you know, hop in Discord, throw it out there. But we're pretty close to getting there. Chronimus, what does 1 mean? So yeah, I can answer that real quick. But again, it's in Discord. If you want to be an engineer, yes, you need to know C++. Okay, but this is why it's hard to answer this question. Do you need C++ for game dev? If you are a modeler, a character setup artist, an environment artist, a texture artist, no, right? If you're generally dealing with anything to do with art, and a lot of times you probably don't need C++. If you want to do engineering or UI or persistence layer or itemization or backend or any of that kind of stuff, yes, you probably need C++. If you are a solo indie dev, it is possible to do it without C++. Inanera, I don't remember the person's name, but Inanera, I believe, is a full blueprint-based single dev project, at least last I looked at it. So it is possible. If you are going to get into some of the deeper wood stuff, like the gameplay ability system, or you're going to use the Lyra project as like a jumping off point, then you're probably going to need C++. So that's my quick answer. All right. All right, y'all. Thank you for hopping in. As always, I hope you all have an amazing rest of your day, a great rest of your week. I will catch you next week for hopefully the final wrap up of the Octa-bot series, and then we'll figure out what we're doing next. Take it easy.